Hello, this tutorial is about creating linear regression with Excel. This with the purpose to introduce to the Python machine learning. We have created this table with y and x values. This x minus with this mean symbol for x and for y, and this is the summatory of x minus the mean of x equal for y mean. This x minus x mean at the second power, and for y we have these values right here, and this is the mean value. The mean value, you can do it with Excel with a very simple tool. Copy paste our values, and there you input the equal sign, and then average in English, in Spanish this. And then we select from our first to the last number. Input and enter. This is the average for our x value. This is the average, and for x and for y. The same procedure for y. And this means that x minus the mean of x, telling the Excel to subtract this 4 sum of 4 of this minus this. We have this value, our first value, and then on and on to this last value in this same sequence. And samely for this y procedure is the same. This is the summatory of this value multiplied by this value. This value for this value gives this multiplied by this is this. This multiplied by this is this. This multiplied by this is this. For these two terms only. This summatory is this cell in this column, that is from this to this. And then this is the x minus the mean of x, squaring it. And then to get this value, you use this in the second power. You use this in the second power, this in the second power, this in the second power, and so on and on. This is equal the summatory of this, and for y is the same. This in the second power, this in the second, this in the second, and the summatory of this is right to this. And then we have these equations, the equations for our linear regression. The principal formula is this one: y equals to a, y is equals to a plus b for x. To get the first value of b, we need to use this formula of R that is equals to this, the summatory of this row that is inside this row. The summatory give this value. Remember, this for this is this, this for this is this, and then the last row we have to sum this all from this to from here to here, and to give this value that is this value in this formula. And then followed by that is some similar equation, that is, this equation gives this multiplied by this, but in the summatory. The summatory of this is this. The summatory of this is this. Is this value. And then square it. There they are the solving problem for this. So this is this divided by this divided by the square root of this for this. Then we squared, we multiplied first these two numbers to give this big number, but this number must be squared with this symbol, squared, and then at the moment that we square it, give this value, and then we only remain these two values, 2.3 over 75 approximately, to give the R value. Our R value is this value, and then for the principal equation, that is B is equal to R multiplied by S over S of X, S of Y is equals to the square root of the summatory of this value. This value is right here, over n minus 1. N is the sampling. The sampling in this table. We have 10 numbers for X and Y. X 10, Y 10. But we use the total amount of rows in these columns that are 10 numbers. Okay, 10 minus 1 is equals to 9, and then we have this is squared values. This is the formula, the summatory of this that is the 67 squared like in this squared symbol right there, and then 10 minus 1, that is 9. We separate our our top part in this equation to give this number, and then we squared multiplied divide 67 over 9, and then we square it to give this value. The same as for s of x, that is square root of the summatory of these numbers, that is these numbers, and then divided by n minus 1, that is 9, 10 minus 1, that is 9, and then we divide this top number by the down number, and then squared, and we have all the terms to get the value of b. Then when we operate over b with our results, we divide at first glance 0.91 over 1.01 to have this value, and then we can multiply this value by this value to get the b value. And then our second formula is to get the a value. The a value is equals to the average of y, the mean of y, that is this value, minus b, that just got it, the b, that is this value, multiplied by the average of x, that is this other value. And then when we get these values, we operate over them. At first we multiply the b by x, the mean of x, to get this value. We have this value, and then we subtract the mean of y minus the result of our multiplication, and then we have the value of a. When we get the value of a, we operate over y, the last equation. The last equation tells us to multiply a plus b multiplied by x. The x can be any value. You can input one of these values, approximate to one of these values. I got this 5.25. The average can be 5, and then I input this 5 as x, but you can choose any other value that approximate to one of these 10 numbers, and then operate over them. We have the value of a and b. You choose the x to get the one input of y. It depends on the value you input in x to get one value output of y. When you I introduce this 5, and then I operate over this equation, and I got this 5.1818, and then I got these values. If I input 5 in x, I got 5.18. Okay, and then I will going to use our graph. This is our graph for these 10 numbers, y and x and y. Our point in x is in 5. Another point in y is in 5.17, 5.18, sorry. That is about to be right here in this point. But as linear regression, we need to chart a line that this line is to predict errors or avoid spending time in useless data, or to analyze data and taking one proper decision. As we know the tangent line, not even. I open this calculator to introduce the formula of the tangent line, the tangent. The tangent is equals to y over x, and then for y, that is to be this. In x, that is gonna be 5. We got this 1.03, and then we need to possess one table for the tangents. In our value, that is 1.03. We search for this value in our chart to get the angle. That is 1.03. It's about to be 47 degree. 47 degree in this part. 5 of x and 5 point some of y. We chart a line of 57 degrees that is to be in this position, inside this position. And then with that data, then we can analyze with logistic regression. This line runs from here to here about and touches these points like grapes. Right here, this line this similar to the grapes. With those data, we have one idea of what is linear regression using these formulas. This formula is very useful in probability and these formulas are very useful such as in this linear regression and probability. And then this is all about this linear regression. The following video is gonna be the logistic regression. To be then later implemented in Python and in machine learning. Thank you so much.